Hello everyone, today I'll show you how you can make your own tools in Unreal Engine 5.2 with the new Scriptable Tools Framework. I've seen the demo that Unreal Sensei showed with the new features for Unreal Engine 5.2, and in the end of his video you can see he created a tool that he can place random objects from a list with random rotation, with the scale being determined by how long he drags the mouse when placing the object. In this way he can easily populate the scene with different objects. Here he shows this example with a list of trees. I've decided to make the same tool and make a tutorial how to do this, because he doesn't show how you can make this tool. This is the tool that I created based on his example. I have list here from 7 objects, and by clicking and dragging I'm placing a random item from this list, and I can change the size. They're always placed with random rotation, and this way it's very easy to populate the scene with such random objects. Let me delete all the actors that I created. First, you'll need to load the new Scriptable Tools Framework. Click on Edit, Plugins, and here type Scriptable. And make sure that you load the Scriptable Tools Framework and the Scriptable Tools Editor mode. They're both experimental features, so if you're watching this tutorial far in the future, some of the nodes may have been changed, but I'll update the video or I'll post the changes in the comments. So after you load these two plugins, then you'll be prompted to restart the editor. After you restart it, you'll be able to use the new menu here. And when you click on the menu type selection, the last one is Scriptable Tools. It will be empty for you. I have now just one tool, this new spawner tool that I showed you how it works. To create a new one, click somewhere in your content browser. I have created a folder for this called Scriptable Tools, and with right click, then go to the editor utilities and editor utility blueprint. Here type Scriptable. And for this tool we'll use the Scriptable click drag tool, because we're using the drag event to determine the size of the object. So click on this, click select, and let's call it spawner tutorial. I'll be referencing my original tool when creating this new spawner tutorial tool, and I'll be using this Scriptable property set. To create this property set type for the spawn object properties, just right click, create a blueprint class, and here write property set and choose the Scriptable interactive tool property set. Let's call it spawn object properties tutorial. Let's go inside this new class. We'll need some variables here to start. I'll start with a mesh, and I'll use this type as a static mesh. Let's choose this static mesh object reference. It's called mesh, so compile and save. We'll use this type in our new spawner tutorial Scriptable tool. So in this blueprint for the scriptable tool, double click, and here for the tool name, let's call it spawner tutorial. Let's compile and save this tool. And if we reload the menu, we'll have the new spawner tutorial class here. If I click it, it will be activated. It will not do anything, but we have it here in the menu now to be used. Go into our new spawner tutorial and let's override the onScript setup event, and let's override the onScript shutdown event. OnScript setup, we want to, let's remind you here, OnScript setup, we'll start with creating a property set of type, and this type will be our spawn object properties. For this tutorial tool, it will be add property set of type. The type will be spawn object properties tutorial. The identifier will be settings, it is fine. And when we succeed, we'll restore the settings that we'll save here on script shutdown. So on script shutdown, let's save property set settings. Now let's create one variable here called property set, for example. Let's change the type here to scriptable interactive tool. Interactive tool property settings. Now let's set this set here on success, and we'll use this to save the property set. Here it will be the mesh, and here we'll restore property set settings. The property set will be this one that we are creating. The save key will be mesh, and we'll save this into our property set variable here. So on script shutdown, we're saving the mesh that we have chosen for our tool, and on the script setup, we'll restoring the mesh that we saved on the last time that we used the tool. So compile and save. Into this spawner object properties, we created this static mesh. Let's choose some basic mesh for default value. Let's, for example, choose this cube. So now if I choose this new tool, I don't see anything here. That's because into our spawn object properties tutorial, we have not set this variable to be instance editable. Let's check this boolean property here. Let's compile and save this. And now if I choose the tool, it will show me the mesh variable, and I can change the model here. I have the default cube here. If I change to the arrow, and if I click complete, the next time that I open the tool, it will choose the same mesh as I have before. This really helps when you are using this tool for placing objects in your scene, especially when you have this list as an array. We'll make that later. If you have, for example, 20 models here, you'll not need every time to reselect all the 20 objects. That they will be saved every time that you close and open the tool. So this is the first step that we want to create with this spawner tool. The next thing is we want to show this mesh when we're hovering any object into our scene. So let's override on hover begin function, and on the hover begin, let's see the original function that I created for the tool here. On event hover begin, we're getting the hover position, we're breaking the ray, we're using the ray to get the origin, and we're calculating the line trace from our camera to our the direction of our objects that we're hovering into our scene with this calculation here. So let's recreate this into our scene. Let's split this pin. We are using this hover position world ray. We are breaking this ray, and we'll use this origin and the direction to do a line trace by channel. We'll use the origin for the start, and for the end position we are using this calculation here. We are adding the origin to our direction multiplied by a very high number. So drag here, click add. Here we'll add just one number, so right click on this vector here and change this to float. So direction will multiply. Change this to float as well. Right click and to float will multiply by a very high number. Connect this. Actually, this should be vector. So we'll reconnect this, and we'll connect this to the end. So we are tracing from the origin to a very far point into the direction that we're pointing the mouse in our scene. And if we have a successful hit, so we are checking if we have a successful hit. Let's create a branch by holding B, clicking here into our blueprint panel, connect this, and return value is our condition. This return value will be true if we have a successful hit. And if we have a successful hit into the original tool, you see that we are getting, let's skip this part, we are not dealing with the random rotation currently, but we're spawning actor from class. We are setting this actor to this preview mesh variable. So let's click here, make a preview mesh variable. It will be of type static mesh. If we have a successful hit, drag him here from the true pin and spawn actor from class. The class will be static mesh actor. Actually, the preview mesh variable should be static mesh actor as well, so we can connect it to this spawn actor from class node. Let's connect this to our preview mesh variable, and for the location we'll split this pin here and we'll get the location from our line trace hit. Let's use this pin here. After we set the preview mesh, let's set the static mesh for this static mesh component. And for this new mesh, we'll get editor property, and the editor property will be called mesh. This is the name of our variable into our into our spawner object property tutorial type, we need to connect the property set here, and into this property we'll search for the variable mesh, and we'll set this value as the mesh into our preview object. Let's compile and save this. Let's test our tool now. Click on the spawner tutorial tool in the Scriptable Tools panel. And when you hover over the terrain, nothing happens. We forgot one important step. So if you open the tool, make sure the quasi defaults here is clicked, and you want to check the want mouse hover boolean here to be set to true. Compile and save the tool again. And now if we activate the spawn tool, if I hover somewhere over the terrain, we'll have the preview mesh set with the object that we select in our mesh variable. Let's make the function that will update the position when we continue to hover the mouse over the terrain, and the position will be updated under the mouse in each frame. Open the tool and let's override the onHoverUpdate function. Let's go to the onHoverBegin that we just created now, and let's copy all the code from here into the onHoverUpdate function. Let's connect the line trace to the beginning. So we are doing the same line trace. We'll split here the array. We'll use the world array for our line trace. And if we successfully have a result from our line trace, we will not spawn the actor because we already have the actor spawned into our hoverBegin function. So we'll check for the actor. So drag here the preview mesh actor, right click, convert to validator. If we have a successful hit, if we have this preview mesh, we'll update the position for our preview mesh. So we'll not spawn here this mesh. Instead, let's set actor transform. Let's split the transform and let's set the location to our out hit location. And because this is in our onHoverUpdate function, it will execute each frame. So each frame will update the position to our new hovered position. Let's compile and save. We have an error here. We need the actor, so drag the preview mesh here and connect it to the target. Compile and save. One thing that I forgot to mention is that in your line traces for the hover functions, you need to add the preview mesh into the actors to ignore, because if you don't do that, let me show you what happens. If I remove the preview mesh from the actors to ignore, you're always hovering over the mesh that you're previewing, so you need to exclude that from the actors to trace, this line trace. So control drag the preview mesh, connect to the actors to ignore, and it will make an array with just this element. Do this for the onHover update function and onHover begin function. And now the tool will work fine with the hovering. And now if we test the tool, when we hover somewhere over the terrain, we'll create the preview mesh object, and on our hover update function, we'll move the object to the location of our mouse each frame. Let's click on complete. What we need to do next is when we click, we want to place the mesh, our preview mesh, to be set as a actor in our scene. So it should be placed permanently into our scene. Let's check the tool that I have created before to see how is this done. So on the drag begin event, we are setting some variables. Then on drag update, we're updating the scale. We'll skip this part from now. We'll just start with the on drag end event. On drag end event, if we have a preview mesh, we'll spawn an actor, which will be again static mesh actor. We'll get the location from our preview mesh. We'll get the static mesh component from our preview mesh as well. We'll set this to our new actor. We'll destroy our preview mesh at the end. This will create the mesh in our level, and it will destroy the preview mesh that we are just using to visualize the result from our tool. Let's open our new spawner tutorial class. Let's click here on the function override on drag end. For the drag end, as I showed you, we'll get from the preview mesh the position and the mesh, and we'll spawn an actor like we are doing into our onHover begin. So copy this spawn actor from class node, place it here. We'll use the static mesh actor for the location. We'll get actor location from our preview mesh, set it here for the location. Later, when we are using the random rotation checkbox, we'll update the rotation for our new spawned actor based on our preview mesh rotation. So you can set it up from now. Get actor rotation and connect it here. So we are spawning the actor. After that, we need to set the static mesh for this actor. So drag from the actor here and set static mesh. This static mesh should be set to the mesh from our preview actor. Let's drag here the preview mesh, get static mesh component. From the static mesh component, get static mesh and connect this static mesh to the new mesh for the new actor. Compile and save. Close this. And now, if I start to drag, when I release my mouse, I have an object placed into my scene. So I can click and drag anywhere in the scene, and I'll place an actor. I'm not replacing the mesh with the new one because we are not destroying the current preview mesh. After we create the new actor, let's drag here the preview mesh and destroy the actor. So when we destroy this actor on end of our drag event, then when we begin the hover again, we'll create a new actor into this preview mesh, and it will take the mesh from here. So let's start with the cube. I'm creating some cubes, then I'm changing this to the arrow, and now we are using the arrow model. Let's change this to some other model. Let's test with the sphere. We are now placing spheres. Let's click complete, and I have all the actors placed into my scene. I'll delete them for now. And now let's set up the random rotation for our mesh, because now we're always placing the objects into the same direction as before. So go into our spawner object property tutorial type, create a new variable, call it random rotation. It should be of type boolean, and it should be instance editable, so we can change it when we're using our tool. Go to our spawner tutorial tool, and into our hover begin function, when we create the actor from class and save it into our preview mesh, if we have this property random rotation setup, we'll update the rotation for this mesh. So let's create a branch node by holding B and clicking into the editor. Let's connect it here. And what we need to check is if we have this random rotation set as true. So as we get the editor property for the mesh here, when setting the static mesh for the preview object, let's copy this and paste it here. We'll get editor property for our random rotation variable. Type here random rotation. Connect the value from our variable to our branch node condition. And if we have this setup as true, we need to update our rotation with the random value. So get our preview mesh, set actor rotation, and we'll set the rotation to a random number. So create a random float, multiply by 360, because we'll get a random float from 0 to 1, and we need the rotation to be from 0 to 360. Let's split this pin and connect this to the Z rotation. This way the object will be rotated in our world on the Z-axis. Compile and save. And now, so click on the random rotation checkbox here. Now I see that the rotation is updated on the first frame, but then it's quickly returning to the default rotation. I assume that in our hover update, we are updating the rotation Yeah, here the rotation is updated to 0 each frame. Instead of setting the actor transform here into the onHover update function, let's set actor location. So we are not updating the rotation each frame. We use the rotation, random rotation only on the creation of the preview mesh, and each frame will just update the location based on our mouse position. Compile and save. And now I'll delete all these cubes. I'll click on the tool. The random rotation checkbox is marked. Now every cube is updated with a random rotation value. Click on complete. I'll delete all the cubes again. The next thing that we will do is to change our mesh variable to be an array and to use a random value from our array for the mesh that we are creating into our scene. So we are not just creating the same object every time, but we are picking the object from a list. So go into our spawn object property tutorial type, click on the mesh variable, and here on the variable type, click on this drop down and change this to array. Compile and save. Let's create a default value again. Default value for this array will be one element. For example, this cube model. Compile and save. So let's change our code. When we are dealing with the hover begin event, here when we get the editor property for the mesh, now this will return an array. So when we set the static mesh here, we cannot set it directly to the array. We need to, we'll get a random array item. We'll connect here the array and we'll return this as a new mesh. This get editor property, because we made this node before and we connect it to the set static mesh, it's assuming that this property value is a static mesh. Let's create this as a new node, so it's not assuming the type of this property value. Let's delete this. Let's get editor property. The property will be mesh. The property set will be our variable, and we'll connect this property value to our array. Now it's not creating this make array node because we are already having an array, and we are connecting a random element from this array to the static mesh of our preview mesh. Compile and save this. And now the tool should work as before, but we can have multiple elements. It's randomly picking from the list of elements, different model each time that I'm clicking. I can set the random rotation variable to true. Now each element also have a random rotation. The last thing that we need to create is to update the size of our mesh based on the distance that we drag our mouse. Let's delete all these models. And now let's continue with updating the size. I'll open the already made tool to show you how I've done it before. When you start the drag event on drag begin, I'm setting up two variables for the X and Y position of the mouse on the screen. Then on updating the drag position, I'm using those values and calculating based on the current position of the mouse this size calculation function, and I'm setting the scale based on this calculation and updating the scale for our preview mesh. And after that, I'm using this saved scale when I create on drag end the final mesh to set the actor scale 3D to this new scale value. Let's start with setting up these variables into our new tool. Open the spawner tutorial tool, override the onDragBegin function. Let's create the new variables. Start X, this will be a float value, then start Y, float again, and scale object float again. So onDragBegin, let's split this pin, and we need to use this start position, screen position. Let's split this pin again, and let's save those two variables, out-drag them here into the blueprint panel, and save the X and Y position to these variables. Compile and save. Now let's update the onDragUpdate position function. onDragUpdate, split again this pin, split the screen position pin, and we'll use those new positions to calculate the scale of our object. Control drag the start X and the start Y, and as I showed you in the original tool, we are subtracting from the start position the current position. We are taking the absolute value, so it will always be a positive value, and then we are running through this size calculation function, which now I will show you how to do it. So subtract the new values from our original saved ones, the absolute value, and then we need to use those into our size calculation function. Let's see the size calculation function here. This is the basic way of calculating the distance between the 2 points. So you're taking the square of one of the sides, adding it to the other square, and taking the square root of that to find the third size. And I'm dividing this result by 100 because I'll get too big of a number, because the scale in Unreal Engine is in centimeters. I'll get a huge number, and I'll just delete that to get the scale. Divide that, sorry. Let's create this new function into our spawner tutorial tool. On the function panel, click on the plus sign, call this size calculation. Here into the inputs we will need two parameters. One will be start X, the other will be start Y. Actually, it will not be start, it will be just X and Y. The two sides, they will be of a type float. And now I'll square both of these values. I'll add them together. I'll then take the square root of this result. I'll divide it by 100 to get a more reasonable scale number. And then I'll save this as an output of the function. So select the function, and the outputs panel, click the plus sign, and we'll output one variable called size. Connect this result to the output variable, compile and save. Then if I go back to the onDragUpdatePosition function, I'll drag here the size calculation function, select this and click on the pure button. That way we can just connect the variables and use this output. And with this output we'll set the scale object variable. So I'll drag this variable into our panel, connect it to the dragUpdate function, connect the resulting scale size from our size calculation. Now when we begin the drag, we are saving these variables. When we continue to drag the mouse, we're updating the scale object variable, and we are still not using it. So let's go back here into the onDragEnd, and onDragEnd, after we set the static mesh, let's set scale of our spawned actor, set actor scale 3D, connect this, and we'll use our scale object variable. We'll split this pin and connect to all of them. We also need to update the scale on our dragUpdate to see the scale of our preview mesh, to decide if the scale is right for our object. So go into the onDragUpdatePosition event, and at the end control drag the preview mesh here, set actor scale 3D, and use this scale object variable for all the three inputs for the scale. Now let's compile and save. Go back into our scene, click on the tool, and now if I click and drag anywhere in the scene, I'll be able to scale the random objects that are being placed. I have the random rotation enabled, and I'm able to place an object with any scale into the scene. Thank you for your attention. If you have any questions or any other additional requests for tutorials, please write in the comments. You can like and subscribe the channel if you like this tutorial and want more of this. And I'll be trying to create a new one sooner. And I'll see you next time. Bye.